We have here a system of equations that, as you can imagine, we're going to attempt to solve. So we want to find the one-ordered pair that's going to work in both of these at the same time. If you recall, when we use substitution to solve a system of equations, that sometimes one of our equations wasn't set up perfectly for substitution, right? We didn't have an x or a y isolated or sitting by itself that made it easy to substitute into the other equation. So we had to, in essence, fix it, right? We had to get an x or a y by itself, rearrange our equation. Well, when we use elimination, sometimes something similar can happen. We don't necessarily have two variables that are just automatically going to cancel each other out. Elimination works really well when we have coefficients that are inverses of one another, a 3x and a negative 3x, or a 2y and a negative 2y. And you can see in this case, we don't have that. So again, we're going to have to fix one of these equations so that we can get either x or y to cancel out. So the way we decide that is, really we can use either one, but we'd prefer to pick the one that would be easiest to cancel. And when I look at the coefficients of x, I notice that 3 is a factor of 6. So I could easily multiply that top or red equation by something and get coefficients that are inverses of one another, right? A 6 and a negative 6 would be perfect. I can get my x's to cancel. So what I'm going to do is take that top equation and multiply it by 2. And that means multiply every part of the equation by 2. So the 3x is going to turn into a 6x. The 2y is going to turn into a 4y. And the negative 2 is going to turn into negative 4. The second equation I'm not going to do anything to because it's already got negative 6 as the coefficient of x. So those are going to cancel nicely. I'm going to keep that one the same. Now there are times when we do need to multiply both equations by something, but this is not one of those. So now I can use elimination. Right, I'm going to add my x terms together and they're going to cancel. I'll add my y terms together and get negative 1y. Add my constants together and get negative 2. So if I divide both sides by negative 1, I get a solution of y equals 2. And just like in every other situation, once we find one of those values, we have to substitute it back into one of the original equations and find the other one. So I'm going to substitute 2 in for y into my initial red equation, the top one. So that's going to turn into 3x plus 2, but instead of 2y, it's going to be 2 times 2 is equal to negative 2. Or 3x plus 4 is equal to, that's supposed to be a negative 2, is equal to negative 2. So now I will subtract 4 from both sides. And I get 3x is equal to negative 6, or x is equal to negative 2. I have just solved this system of equations. X is negative 2, and y is 2.